Hello everyone, welcome back to my YouTube channel. I apologize for my absence, but I've been experiencing some back pain lately and I needed to take some time off and rest and recover. But now I'm feeling much better and I'm excited to be back. So, in my last tutorial series, I showed you how to build a dairy farm management project with Django, and we've been working on building the admin site on our front end. However, I've decided to pause the tutorial for a moment and introduce some new logic to the project. And so we'll be adding the dairy inventory management to the project, which will allow us to keep track of the milk inventory and update it accordingly. We'll create two new models in this tutorial, the milk inventory and the milk inventory update history model. These models will help us to keep track of the total amount of milk in the inventory and the history of the inventory updates. We shall also create serializers and the read-only view sets for these models, which will allow us to retrieve the inventory data from the backend, or rather the database, and avail it to our Angular frontend. And by the way, I have some exciting news to share with you. I'll be transitioning to using Pycharm as my primary IDE for this project. So while I've been using Visual Studio for the backend, I think Pycharm will provide me with better features and tools to build this project more efficiently. So the outlook is just similar. So this is the VS Code, and then this is the Pycharm. You can see the folder structure and everything is just more or less the same. So in order to get this Pycharm IDE, you head over to the browser of your choice. You can use the Edge, the Chrome. Now I'm using Safari. All you need to write is Pycharm IDE and then search. Pycharm IDE is developed by the JetBrains, so it is this very first link. Click on it, and then all you need is to do the download. So it will take you to this download page where there are different operating systems. If you're using Windows, then you'll click on it, then download the executable file. Now there's the professional and there's the community. The professional is the paid version. I'm using community version, so there's no harm if you download this one as well. So you can also use the macOS or the Linux operating system dedicated Pycharm. So first off, let me say that I've been using Visual Studio Code for a long time and it's a great editor for many different kinds of projects. However, when it comes to Django development, I've found that Pycharm has some distinct advantages. One of the main advantages is that Pycharm has much better support for Django than Visual Studio Code. Pycharm has a built-in Django template editor, Django-specific code completion, and debugging tools that make it much easier to develop and debug Django applications. Even though the community edition doesn't have built-in support for the Django support, you can install several plugins that will allow us to have access to most of these features that are available in the professional Pycharm version, this one here. And another advantage of Pycharm is that it has more complete set of tools for managing your Django project. For example, Pycharm has the Django manage.py console built in, the command that we use to run the wake up the server or run the server. And we also use it to execute other management commands within Django. So Pycharm has this built in, and this lets us to run the Django commands right from the IDE. And it has built-in console that lets us interact with our database directly from within the Pycharm, just like the Visual Studio Code. Finally, one of its biggest advantages is its excellent code analysis and debugging tools. Pycharm can help you catch errors before even you run the code, thanks to its intelligence code analysis and autocomplete features. And when you do run into errors, Pycharm debugging tools make it much easier to track down the source of the problem. So if you're working on a Django project, I highly recommend giving Pycharm Community Edition a try. Even if you're using Visual Studio Code or another editor, you might be surprised at how much easier and more efficient your development process can be with Pycharm. In the download page, you have three tabs: the Windows, the macOS, and the Linux. So make sure that you download the one that works with your system. So if you're a Windows operating system, all you need to do is to click on the Windows, then download the exe file. If you're on macOS, you download the DMG file that works with your system, or if you're on Linux as well, you can just download it this way. So for me, I've already downloaded mine, and that's why I already have it installed. After you download it, you click on the top left-hand corner of the screen. There's a file, click on open, and then you navigate to the folder where this project is installed within your PC. So just like that, and you click on open, and it will be open like this. And by default, if you open your project the very first time, Pycharm looks for the readme file and displays it at the very first file that is open within your editor. So, in my last tutorial series, I showed you how to build a dairy farm management project with Django, and we've been working on building its admin side in the front end. However, I decided to pause that tutorial for a moment to introduce some new logic to this project. We will be adding inventory management to the project, that is the dairy inventory management logic, which will allow us to keep track of our milk inventory and update it accordingly. We'll create two new models, the milk inventory and the milk inventory update history model in this tutorial. These models will help us to keep track of the total amount of milk in the inventory and the history of the inventory updates. We'll also create serializers and read-only viewsets for these models, which will allow us to retrieve the inventory data from the backend, that is the database, and avail it for the front end, or rather displays it to the front end. Once again, welcome back to my channel, and I hope that you are excited as I am to continue building this dairy farm management project with Django and Angular. So let's get started. So we shall head over to the terminal, give it some few seconds to activate the virtual environment. Well, that's great. Now check on the directory where we are. So we changed our directory into the backend directory, that is efarm. So in this tutorial, we shall be adding a new app, that is the dairy inventory app, and the command is Django admin start app dairy inventory. So after we've already have that, all we need to do is to click that, then Django will go ahead and then create the app for us. And so Django went ahead and created the app for us, the dairy inventory app, this one here. It has these several files inside it. So we shall be starting with the models.py file, where in the interest of time, I'll be just populating the models and then explaining them line by line. So from the start of the tutorial, I said that we shall be having two models in this app for the start, that is the milk inventory model and the milk inventory update history model. So the very first model, the milk inventory model, represents the current inventory of milk in our farm. So it has two fields, the total amount in kgs and the last update. The total amount in kgs will act as the store for the amount of milk that we have in stock in kgs. The maximum number of digits is 7. It has 2 decimal places, and it validates that the minimum amount should be 0.00. This field is marked as non-editable, meaning that this won't be manually keyed in. And the last update is the date and time when the inventory was last updated. This is a datetime field with the auto now is equal to true, this one here, which means that it will be automatically set to the current date and time whenever the object is saved or updated. The second model, milk inventory update history, represents the history of milk inventory updates, and it has 4 fields: the amount in kgs change, the update type, the amount in kgs, and the date. The amount in kgs change is the amount of milk that was added or removed from the inventory. So this is a decimal field with a maximum of 7 digits and 2 decimal places. This field has a minimum value data that ensures that the field is non-negative value, and it's marked non-editable because all this will be done automatically. The update type field is a character field with a maximum length of 7 that indicates that whether the milk was added or removed from the inventory. The field has 2 choices of added or removed, which are defined by the class update type, this class here. This field is also marked non-editable. And then the amount in kgs field is the total amount of milk in the inventory after that update. So this is also a decimal field with a maximum of 7 digits and 2 decimal places. The field has a default value of 0.0, and it has also a minimum value data that ensures that the field is a non-negative value. So the field is also marked non-editable with the editable is equal to false, this one here. And then this last field, the date, is the date when the inventory was updated. This is a date field with the auto now is equal to true, meaning that it will be automatically set to the current date whenever the new milk update history object is created. Going forward, I shall add a new file, the signals.py file. The reason why I'm doing this is because all these fields are read-only, and meaning that they'll be populated automatically. And so just like the models, I'll just be adding the code and then explaining them. This block of code imports the necessary modules and our models for the signal, and then we define a signal receiver function that will be triggered before the save method is called on the milk model instance. And then this block of code retrieves the amount of milk from the database for the instance being saved. If the instance does not exist yet, meaning that the milk record is being created for the first time, or rather it's being saved for the first time, it sets the old milk amount to be 0. And then we calculate the difference in milk amounts between the old and the new instances and determine if it's an addition or removal of the milk from the inventory. And then this last block of code ensures that the milk inventory is updated accordingly, either by adding or removing the difference in milk amounts. It then creates a new record in the milk inventory update history model to log on the change in the milk inventory. And so, just a quick recap of how this signal works. First of all, we check if the instance of milk that has been sent by this pre-save signal has a primary key. That means that that milk record will be updated. Then we set the old milk amount to be the previous amount in kgs of that. But if it does not exist, meaning that there is a new milk record, then we set the old milk amount to be 0. And then now we calculate the milk difference between the instance, that is the new milk record, or rather the new milk amount in kgs that is being sent, and we subtract the old amount from it. So we check if the milk difference is greater than or equal to 0, meaning that the update type is equal to the add, then we assign that as the update type. Or if the milk difference is actually negative, then it will be an update type of remove. And then now we update the milk inventory. But the reason why I'm doing this way is, think of this scenario. We have a new milk record in our new database, which means that we won't be having any milk inventory in that database, because technically the milk inventory will only be there if there was also some milk record that are already populating the database. And in this case, we will first of all use the default model objects manager method get or create to check if we have any milk inventory. And of course, we only have a single, or rather we'll be having just a single milk inventory instance in our database, so it will be of the ID is equal to 1. And by the way, ID and PK, or rather the primary key, can be used interchangeably in Django. And so this is how this method works. This returns the instance of a milk inventory and either a true or false for if that is created. So meaning that if it goes and checks the database and finds a milk inventory, then it will return a milk inventory instance with the created is equal to false. Or if it is not there, then it will create a new milk inventory object with an ID of 1. And then so what we do is that, assuming that the case of just the new milk record and the new milk inventory, that means that the total amount in kgs of this milk inventory instance will be 0. And now if we add the milk difference, basically now that here we have the new milk record, there won't be any old milk amount. All we have is just like the very first instance of the amount in kgs will be assigned as the milk inventory. I hope you understand that very well. And so we save the milk inventory, and then the moment that after we save the milk inventory, we will need to fire up the milk inventory update history in order to track what has happened here. So anytime that we save the milk inventory, we will also need to create a new milk inventory update history to create, or rather to associate what has happened here with the new history object. So what we need to do is assign the amount in kgs change, that is the field that is found within the models of the milk inventory update history. This one here will be assigned to the milk difference because it makes sense that way. Then the update type will be the update type that is found here. If the milk difference was above 0, it will be a type of add. If it was less than 0, it will be a type of remove. Then the amount in kgs will be the amount of milk that is remaining just right after the process of either updating, creating a new milk record has happened. So we will assign it to the new milk inventory total amount in kgs. And with that, we now have our models already defined with the signals together with it. Now we need to add a new file, the serializers.py Python file. Okay, sorry, a new Python file, serializers, wrong spelling, serializers, Python file, add it. So in the interest of time, all I'll be doing is just populating it and then now explaining it. So we will be serializing the models, and the first serializer is the milk inventory serializers. which will be subclassing the model serializer. Now we'll be serializing all the fields in this model, that is the total amount in kgs and the last update. We make them read-only because you understand that the signal works and populates all this stuff automatically. Similarly, we do that to the milk inventory update history serializers. All the fields will be read-only. And so now, with our model serialized, we now add the code for the views. Here, I'll also just be populating the code itself and then now explaining. So we will be using the Viewsets. This allows us to perform all the CRUD, but in this case, we won't be having all the create, retrieve, update, and delete actions because these are read-only model viewset. I have defined the model in such a way that all the fields are marked non-editable by this specification of editable is equal to false. So it makes sense to use the read-only model viewsets. I know model viewsets provides the functionality such as the create, retrieve, delete, and update functions, but in this case, we'll only be able to retrieve. So it makes sense because all this stuff, we don't need any manual intervention here. All this will be done automatically just by any save of a milk record. So this is the way we define the model view sets. First of all, specify the query set. So the query set here will be the milk inventory objects. We want to serialize everything, every milk inventory that is within our database, and then the serializer class will be just the serializer that we've defined here, the milk inventory serializer, and that is just similar to the milk inventory update history viewset. So we already have our viewsets, and now we need to map these views to specific URLs. So we need to create another new file, the urls.py file. Okay. And then as usual, I'll be adding the code, then explaining it. So in this case, we first of all import the necessary modules for our urls.py file to work. So we import the views as well. So we instantiate a router instance, and then this router instance we shall be using to register our model viewset. So this base name will be a way in which our router will be using to generate the URLs, so that maybe in future we don't have issues with the naming of the URLs and all that stuff. And then now we pass in the router URLs for the path function in the URL patterns to generate all the URLs for these views. Now in this case, there won't be many because these are actually read-only view sets, so maybe it will be just for URLs for the retrieving both of the milk inventory and the milk inventory update history objects from our database. Something worth noting is that our dairy management system is increasingly becoming larger and larger, and as our Django app starts to grow in complexity, it becomes increasingly important to make sure that our code works as intended. So unit tests will help us to do this. They will allow us to write small isolated tests for different parts of our code to make sure that they work as expected. And so let's get started. First, let's create a new folder named tests inside our daily inventory app. So it will be a new Python package which will be of name tests. Add it. So this folder will be containing all the unit tests that are responsible for our daily inventory. And inside the test folder, we'll create a new file named testmodels.py file. Testmodels.py file. Then save it. Then we also add this one. So I'll populate the signals code. So this is the code. The first 4 lines we import the necessary modules and the models for this test case, the milk inventory model test case. And then we define the method, the setup method that is provided by the base class of the test case. This allows us to initialize the data and the objects that we shall be using in the subsequent functions to test the functionality of our models. So in this case, the reason why I was talking of increasing complexity is this. For us to have a milk record in our database, we need to first of all have a cow associated with it. So that cow has to be pregnant as well, and the pregnancy has to have its date of calving available because we have defined our models in such a manner that for a cow to have any milk record entry, it has to have a active lactation. And so this is how it works. We first of all create a new cow, the cow of the name Daisy, the breed of Frisian, then the date of birth of 4 years ago. So this translates to around maybe 4 years ago. The day is 1460. And then the gender is female, of course. A male cow cannot be pregnant. Then the pregnancy status by default is not pregnant. Then now we associate a pregnancy object with that very cow. the cow was a foreign key, so we assign that cow as the cow. And then the start date will be maybe 1 year ago, because 300 days is roughly around maybe a year ago. Then the date of calving is now like 2 weeks from today. I hope you understand, because this will be now like the pregnancy duration will be like 300 minus 15. That would be 285 days, and the gestation period of a cow is roughly 280 to maybe 290 or 300 days. So the pregnancy status has to be confirmed. Then the outcome was live because the cow actually gave birth. And so it's worth noting that if a pregnancy object is created, then there is a signal that we had created in our dairies folder, the signals.py. Yeah, this one, the create lactation signal, that actually depends on a post-save signal from the pregnancy model. This means that whenever a pregnancy has its dates of calving availed, then the subsequent code will run, and then a new lactation will be created with the date of calving as a start date of that lactation. So every specific lactation will be tied to a specific pregnancy record. And so with that, now we are sure that we have a cow, and then we have a pregnancy object with a valid date of calving, and then that will actually fire up a lactation. And inside this very specific method, we shall be having a new lactation, or rather an active lactation, and now this cow will be valid to have any milk record entry. So we shall now create a new milk record assigned to that very specific cow. Then we give it an arbitrary value of 20.5 kilos of milk, and then in the lactation field for the milk object, we set the lactation to the lactation that has been created and is associated with this pregnancy that has been created with the date of calving. So we shall do the reverse query of the cow.lactation underscore set. So this is a way in which Django allows us to do the reverse query, because literally lactation has the field of cow, but the cow does not have the field of lactation. So having the underscore set allows us to get the most recent lactation record. And so we shall be having the cow, the pregnancy, the lactation inside under the hood, and the milk record. And so we'll go ahead and now write in the function test, or rather the methods that will be testing this. So in the very first method, or rather the function, the test milk inventory creation is quite descriptive. So we shall be testing if the milk inventory is created whenever we add a new milk record. So in this case, since we had the milk record already initialized in this our setup method, meaning that technically we already have the milk inventory already created. So we first of all retrieve that milk inventory, then assign it to this temporary variable of milk inventory, and then this assert equal compares two values. In this case, we compare the milk inventory total amount in kgs and the 20.5. So bear in mind that this is the very first milk record that this class encounters. So that means that our milk inventory will be having a 20.5 kgs of milk as the total amount. So we compare what we have in the milk inventory and the actual amount of milk that we've initialized this class with. And then we head over to test also the update history creation. So what we do, we first of all retrieve the milk inventory and then compare as well. And then we create another new milk record, then assign the cow to be the self.cow, this cow that we've created in the setup method. I've said that this setup method is run before each and every test. So it's like it's the store for the resources for our test. So meaning that this cow will be having two milk records of the 20.5 and the 10. So meaning that if we add the 10, so we shall be having a milk inventory of a total of 30.5. And so we check if the milk inventory total amount in kgs is updated to 30.5. And now since we have our milk inventory update history dependent on the changes, or rather tracking the changes in the milk inventory, so we will retrieve that as the very first milk update history, and then we do the comparison. We first of all check if the amount in kgs in change is 10 kilos of milk, because actually the first one was 10. Then now if we add, no, the first one was 20.5. So the second milk entry, or rather the second milk record that we are adding, is at this place where it's 10. So meaning that the change will be 10. We also confirm if that is true. So the test will check that. And also if the update type, now that we are adding 10, so meaning that it will be a type of add, then as well we check the milk update history amount in kgs if it totals to 30.5. So now that we're done with the tests, one more thing that's remaining is to make migrations, actually to apply the new models to the database for our new daily inventory app. And to do so, we need to run the python manage.py, make migrations. So if we do that, then it will go ahead and create all these migration files. So let's focus on these migrations for the dairy inventory. It created the milk inventory and also the milk inventory update history. So after doing that, we now actually, or rather after creating the migration files, all we do is actually apply the files into the database. So after doing that, now all we need to do is to run the python manage.py, stop.py, run server. So the server is now up and running. So we shall go ahead and check if our endpoints for the serializers, especially the data inventory, URLs, views, and the models is working. So let me reduce this terminal a little bit. And so we shall be navigating through the URLs of our endpoints. In our data inventory app, we have the URLs of endpoints at milk inventory and the milk inventory update history. So all we need to do is to cross-check. First of all, this is a very base URL. So this is how Django works. It first of all goes ahead to this URL, the localhost port 8000, then checks any matching URL. So in this case, now that we are working with the data inventory, so it will go and check if there is a URL matching pattern of the data inventory. So in this case, I copy this. So after I copy that, then all I need to do is to add it over there. And then I go ahead and as well check now the local URLs for our data inventory app. So it will be localhost data inventory, the one that I've copied, and then slash. Now let's start with the milk inventory. So I'll copy that and then paste it over there. Wow, it actually works. It's empty now, but I think we do not have any milk record in our database, so I'll go ahead and check if we have any. So I'll be using the default Django admin. So we have that. First of all, I will check if there's any eligible cow. So yes, we have a cow of 2 years, then it's a female. Cow number 2. If there's pregnancies, yeah, meaning that, okay, that one ended. And then, yeah, we actually have an active lactation here. So I'll just go ahead and add a new milk record. So the reason why this one is empty, but we literally have some milk record in our database. These ones we added probably in the last tutorial and just a while. So by that time, we did not have any data inventory app already associated with our project, so it was not tracking them. So for now, I will go ahead and add a new milk record and check if everything works well. So the cow number 2 of 20. So today is April 11th, and let me check. Refresh that. Oops, it's still empty. So what I'll do is I'll go ahead and check what's wrong. So that means that whenever we save any of our milk record, meaning that there is no signals that is fired, because actually that's the main cause. So what I'll do, I'll first of all check if our signal is okay. The update milk inventory signal seems to be okay. And what might be wrong? So okay, let me check. By the way, the signal might not be registered. Oh sure, the signal had been registered. So to register a signal, we need to define a method called the ready method inside this app.config. So this will inform Django that there are signals in this app, so they should be fired. And so in this signal, we shall register our data inventory signal, that is import the data inventory signals. And now we've registered the signals, so I'll head over to add a new milk record and to test if they work actually. I'll add a new milk record for the cow number 2. give it maybe 10 kilos of milk, save it. And now we have this error of the unsupported operand type, float, and the decimal. So this trace back for the errors. Let us check where the error is coming from. Okay, it's coming from this line number 28 in the signals.py. So line number 28 in our signals.py is here. So this was a decimal field, and let me check the type of the milk difference. So this is an integer field, so it makes sense. Let me wrap it under the float so that we change the value here to be a float and then check it out again. So if I send the same request to the server again, it saves successfully. And now our milk inventory update history should be having a single record. Yeah, so and now that today we've added the two models, the milk inventory and the milk inventory update. So we have the amount in kgs to be 10 because actually that's the very first milk record that we have, the update type, and amount in kgs and the date, that is today when I'm recording this. So well, that's now working. So one more thing that I'd like to mention is that the fact that our code is becoming much more big and it's growing, so there was a need for writing tests, and I went ahead and created this folder, the tests folder, and actually populated the tests code for our project. So in order to test, because in future we won't be actually doing everything manually just like I did here, over here we want the code to test itself. So I'll create another new instance for the terminal, some few seconds to activate it, then now change directory to efarm folder. To write our test, all we need to do is to write the python manage.py, wrong spelling over here, so I delete that double A, then add another A here, so it's python manage.py, then we specify this is a test. So what we need to do is now we specify the app that we are going to test, so it's dairy inventory. If you just leave it like that, it will test everything, it will go ahead and test everything. So it's dairy inventory, and then in the dairy inventory we have another folder called the test. So if we do that and run our two tests, we see this rain 2 test is okay. So it means that our milk inventory creation is okay, everything is working okay, and also the milk inventory update history creation and all that stuff works okay. And so now we are quite sure that our code is working and we won't have to worry about any other thing that might happen. And before I finish this tutorial, there is one more package that is very crucial for our project. So I'll head over to the browser. The name is Django Extensions. So if you search for it, here it is. So we shall install it in our project. So just come here, paste the line of code, pip install, then it shall be installed. All right, now it's installed. So in order to use it, first of all, we go to our installed apps in the settings.py file, then add this line, the Django extensions. So that's what I'm doing right now. So this is our main projects folder, and in the settings.py under the installed app list, so we shall add the new app, the Django extensions. And so now that we have the Django extension already listed in our installed apps, and as well we've already installed it, there's one more thing remaining. Copy this line of code, the python manage.py. So we shall be using this to generate an image that shows our models and the relationship. So I'll edit this line a little bit, customize it based on our project. So actually the image file that will be generated will be of the name efarm models.png. But let me just explain a little bit of what this line of code does. So the python manage.py is just the normal management command for our Django. Then this graph models, meaning that we shall be executing stuff related to the Django extensions, and then the -a specifies that we shall be generating the image for all the models in our application, and in this case we have the two apps of the dairy and the dairy inventory. Then the -o means that the output, so the output would be the efarm models.png. So if I click on that, some few seconds, and then we are back to this. So if I go to our folder structure, we see this new file, the efarm models.png. So let me collapse all this and then open this image. So I'll zoom a little bit. We have several models. You remember the insemination, there was the semen, the inseminator, there's the culling, pregnancy, then there's the cow here. So all we want to see is the two new models of today. We have the milk and the milk inventory and the milk update history. And by the way, you can see there are a lot of relationship that there are between these models. For example, there's this lactation, then some little bracket, let me expand it a little bit, lactation milk, meaning that we have the lactation as a foreign key inside this milk model. We have the milk inventory. Of course, these ones are connected. The milk and the milk inventory and the milk inventory update history, these ones are connected with signals. So currently, this type of generation does not support, or rather does not check for the signals, but this is something that is worth noting, that we are able to generate all the relationship and the models that we have and have a quick look of how they are interconnected. So our main model here is the cow, and as you can see, it has very many arrows from it. So there's the cow linked to pregnancies, linked to culling, linked to heat, and all that stuff. And so I believe that's enough for this tutorial. In the next tutorial, I shall be continuing with more logic about the dairy inventory, as well as also adding new app, that is the dairy sales, to handle everything to do with the sales and all that stuff. Furthermore, there's also another new app that is in line that will be dealing with the dairy feeds. I hope you realize that this project is becoming larger and larger, and it's quite interesting. So please turn on the notification bell, share, subscribe, and if you see anything that you don't understand, or rather you have other new suggestions, please don't hesitate to reach me out in the comment section. Thank you, and see you in the next tutorial. Bye bye.